this second exercise, which is exercise 9.57, page 158. So this one. Okay, so hopefully you can see it clear. Okay, this question. Okay. So we have two components A, B, and the other one is C, B, D. Okay, attached together. The question is determine the reaction at pin A and C. A and C, so that the system is maintained in equilibrium. Okay, so of course, in this case, the question asks you to find the reaction force at these two joints, A and C. So of course, I will start by using the overall free body diagram. I will not go one by one first because it involves these 2 points, one here and one here. If I'm using only this part, I can solve only one. If I'm using this, maybe this. Okay, so if we start by using this overall free body diagram first. If later on we cannot solve using this one, if there is too much unknown and so on, we can go one by one later on. But we better start by using this overall free body diagram first. Okay, so identify if there is any two force member first. Okay, in this case we have for this part we have point A that can have forces. We can have force one here, one B. Okay, because there's a pin joint here, and we have another external forces at this point. Okay, so 1, 2, 3. So this part cannot be a two force member. Okay, point CBD, one here that have pin, the other one is here that have pin. So we have 2 points. We have another point at D, but there is no external forces at D. If there is any other external forces at D, there will be the third forces. But now we only have 2 points that have force, so this part can be considered as two force member. Okay, no mass, no external forces. Okay, only these 2 points that can have force. Okay, so we go one by one. A, open this one, so I have AY, AX. At B, we didn't open, so nothing. But at A, first we put the external force, which is here we have this one. What is the value? Should have value here. What is the value? Where is it? Where is it? kilonewton. So 12 kilonewton. This here is 12 kilonewton. Given 60 degree, so here is 30 degree. Okay, 30 degree done. So we have this one. If I open this one, I will have CX, CY, but since it is a two force member, so join these two lines. Okay, and one force may be this one, if I'm considering its intention, which is FBC. Okay, you can calculate what is the angle here. Okay, because we have this part, this is 1, and this is from here to here, 0.5 and 1, so we have this kind of thing. 1.5, this is 1. Okay, 1.5 and 1, we can calculate the theta here, which is at the end minus 90 degree to have, you can calculate alpha, and this is theta here. Okay, so go, first put this way, tangent minus 1, 1.5 divided by 1 equal to, so 90 minus answer, 33.7 degree. Here is 33.7 degree. Okay, so now by drawing this free body diagram, we notice that we have 1, 2, and 3 unknown. Only 3 unknown. Okay. So we have three choices: sigma fx, sigma fy, and sigma moment. Again, if I start by sigma fx, I will have this one and FBC, two unknown. I cannot solve from that first equation. If I'm using sigma fy, 1 and 2 unknown, still I cannot solve from that two equation. I have to solve that simultaneous equation to get the answer, because I have 1, 2, and 3. Okay, but if I'm starting by using sigma moment, okay, if I'm using sigma moment at this point, FBC, I will have here AX, one unknown, AY, another unknown. Here FBC will be 0, so it's no point. But if I'm using the point A as my moment taken, so I will have FBC with the distance. So directly I will ignore AY, AX. This one is known, so I will have directly the value of FBC. So please think first before you start which equation first, at what point you want to take the moment. Okay? If not, we have a lot of equation, but you will have difficulty to solve it. So please analyze first which one is easier for you. In this case, we have moment at A is the easiest one to get the answer, the shortest way to get the answer. So we get the first sigma moment at A equal to 0. Okay, sigma moment at A equal to 0. So here FBC I will resolve into 2 FBC. FBC. So this one is there. This one is here. So still the angle FBCX, FBCY. Okay. Here is also will resolve into X and Y and X direction. Okay. So to not make it a confusion, this is force from here. So when this force is acting here, so I'm resolving one here and one other here, because this is the force. Okay. So to make sure you know that the force is acting on this point, actually not here but on this point. Okay. So because it is important for us to know which point to take which distance. Okay, for the correct distance to calculate the moment. Okay, so we have one here and that. So 30 degree. So here like this one. So we still have same angle here. Okay, so taking the moment at point A. So point A, so we have two force, one here, one there. So I will start by this one. Okay, putting this way, this one is 12 cos 30. Okay, so 12 cos 30 for this one. So 12 cos 30, and we need to take the distance. From here you make a line, and the second line here, the distance between these two, which is, we are here actually. Okay, so we have here is 1.5 plus 0.5 here, so the distance is 2. Put a pin at A, you pull this direction, you push the direction, so you turn clockwise. So here is positive. Now you put a pin here, you pull this direction also clockwise, so plus. Okay, 12 sin 30. Okay, so you have one here. Okay, this is the line, this is the force. So this one, you make a line straight here, and the second line on this point parallel to this one. So you have, this is your distance, which is equal to 1. Okay, equal to 1. So finish for the first one, 12 kN. We go to this part. Put a pin at A, pull this direction, so it will be negative. So minus FBC, this one is cos 30. Okay, minus FBC cos 30. Cos 33.7. Okay, so this is the line. Second line here, so this is the distance. So make it here to there. So it will be 1.5 plus this one is what? This one is 1. This one is taken 1. Okay, this one is 1. So distance is 2.5. Negative because pin here, pull this direction, we turn counterclockwise. Pin here, pull downward, so it will be clockwise. So positive. F, BC. Okay, not the positive and negative because of the direction of F, but because of the direction of the moment. Good. Now you pull downward, so you turn clockwise. Okay, pin that, pull downward, so clockwise. So FBC, down here is sine 33.7. The distance from here, line, second line here, so you have here to this point, which is 0.5. 0.5. So 1, 2, 3, 4. This one is on the point, so 0, 0. Equal to 0. Okay? So from here you have one equation with only one unknown, FBC and FBC. Okay, so you can try to solve this one. 12 cos 30 equal to times 2 equal to plus 12 sine 30 times 1. So you have first here 26.78 minus cos 33.70 equal to time 2.5 to minus 2.08 FBC plus sine 33.7, okay, times 0.5, 0.277 FBC equal to 0. Okay, so put the other way, so you have 26.87 minus 2.08. Okay, minus 1.8 FBC equal to 0, so you have FBC equal to 26.78 minus divided by answer equal to, okay, put the other way, will be positive, so 14.86 kilonewton. Okay, it is kilonewton because this one 12 is kilonewton. Okay, so FBC is, and the direction is correct, meaning that positive from our calculation, meaning that this is 33.7 degree. Okay, this is for the FBC. Okay, so now we have solved the first one. We have two more unknown here, so you can continue. If you use sigma fx, you get the ax. If you use sigma fy, you get the ay. Okay, which one you use, same result. Okay, so I can erase this one. Okay, so I already have the FBC there. So maybe we go sigma fx, positive direction to the right, sigma fx equal to 0, so I will have ax plus FBC 14.86 cos this one, cos 33.7 degree. Okay, I'm taking this one, and minus this part, minus 12 cos 30 equal to 0. From here you have the ax equal to, okay, only 1 and 2 because one from here, the other one is from here. So x minus 14.86 times cos 33.7. Okay, putting the other way, we minus the plus 12 cos 30 up, so minus 1.97 kilonewton, meaning that our ax is actually 1.97 kilonewton to the left. Okay, this is the value. This is the value from the calculation. This is our interpretation of what is meant by this negative. Okay. Continue by sigma f y. upward positive, sigma Fy equal to 0. So you have the first one, this one Ay plus 12 sine 30. Okay, so Ay plus this one minus this one, minus FBC sine this one, so minus FBC. Our FBC is this one. So minus 14.86 sine 33 7 degree equal to 0. Okay, so from here we have the Ay equal to. Okay, so 14, put this one the other way, it become negative, this one become positive. 14.86 sine 33.7. Okay, minus 12 sine 30 up 2.24 kilonewton positive, meaning that it is same as our assumption here, which is upward. Okay, so you have FBC, AX and AY. The question asks you to find the reaction, so you have to combine these two, become the A. Okay, so combination, AX to the left, first here, AX is to the left, this is our start point, plus AY, which is upward here. So we have A. Make sure you understand this correctly. If this one goes there, this one goes there, what is the direction of A? Okay, because there's a lot of students still confused by this one. You know this direction, you know this direction, but still you draw the direction of A, incorrect direction. Okay, so please, you start by, this is the starting point of AX. At the end of the AX, you must plus the AY. Just follow this direction, and the A is from start to the end point. Okay, so and this is the theta. So A is equal to square root of AX squared plus AY squared equal to 1.97 squared plus 2.24 squared. Square root of everything, you have 2.98 kilonewton. Theta is equal to tangent minus 1 AY divided by AX. So you have tangent minus 1 AY, 2.24 divided by 1.97. So you have here 48.67 degree. So your final answer is this one for FBC, and A is equal to 2.98 kilonewton, 48.67 degree. Okay, so this is your final answer in A and for. Okay, so this is your final answer, one for FBC, the other one is for A. Okay. Because the question asks you to find the reaction, you cannot leave in terms of this one. This is the component of reaction. So you have to combine AX and AY to become the A. Okay? So that's all for the exercise. I think that's enough for now. We have two exercises where I showing completely how to draw the free body diagram, and then how to calculate, start by which point, sigma fx, sigma fy, or sigma moment. We have to analyze first. I'm starting from sigma moment first at point B, point A. Okay, you have to choose wisely the point, and then we go to sigma A, sigma fx, sigma fy, interpret what is the value of negative here, and then combine the component to become one single reaction force. Okay, so that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.